Hi, in this lesson we're going to talk about applying right triangle trigonometry for solving some problems. So we're going to remember here first of all is the ratio that we have. So we have sine defined as opposite leg over hypotenuse, cosine is the adjacent leg over the hypotenuse, and tangent is opposite over adjacent. And if we have a right triangle and we know at least one angle and at least one side, we can find the measures of all the remaining sides and the remaining angles by using that, but it has to be a right triangle. So here's our approach. We identify what side is given and what side you need to find. This will help you understand which of these three trigonometric ratios you are going to use. Then you set up an expression using the sides and using the side that you know, the side that you're trying to find, and the angle, and after that you solve that equation. So let's see how it's going to work. Here's our first example. We have this right triangle here. This side is 12, this angle is 35, and the side that we're trying to find is AB. So let me call this X. And then here's what we're trying to determine. For that angle, because the angle is going to determine what you were trying to work with, this is the opposite side and this is the adjacent side, which means we're going to work with tangent. So what we can say is that tangent 35 degrees equals x over 12, opposite over adjacent. Okay, and then you solve this equation. In this case, it is actually easy. You can multiply both sides by 12. And then you are going to get x equals 12 times tangent 35. I do need to warn you about one thing. Make sure your calculator is in degree mode, because it may be that your calculator is in radian mode and it's not going to give you right answers. So we need to be in degree mode. My calculator already is. So I'm going to type in 12 times tangent of 35 degrees, and I'm going to press enter. Hold on. 12 tangent 35, and that's going to give me 8.40. I'm going to round my answers to the nearest hundredth. So this is going to give me approximately 8.40. Okay, this is our answer. Next problem. So let's take a look at what we have here. For that angle here, that one is given to us. This side is opposite. This is the hypotenuse. So opposite over hypotenuse is sine. So we can say that sine of 53 degrees is going to equal opposite, which is x, divided by hypotenuse, which is 15. Similar to the previous problem, you are going to multiply both sides by 15 to get rid of that fraction. And then you are going to get that x. These two cancel, just like these 12s cancel here. And x is going to equal 15 times sine 53 degrees. And then you type it in the calculator. 15 sine 53 degrees. It's going to give us 11.98. Okay, and there's our answer. Okay, next problem. So here we have this triangle. We're given this angle y. This angle here is 51 degrees. And side A here is given to us as 12. And we're trying to find the length of C. So we're trying to find this length. Let me call this x. So for that angle here, this is adjacent. This is hypotenuse. So adjacent over hypotenuse, that's cosine. So we can say that cosine 51 degrees equals adjacent, which is 12, over the hypotenuse. Please note that x is in the denominator here. I'm going to show you a quick trick here. Basically what you do if you want to solve it, you just switch this cosine with this x. And you're going to get x equals 12 over cosine 51 degrees. Okay, so we type it in the calculator. 12 divided by cosine 51, and that's going to give you 19.068, so approximately 19.07. Here's that answer. Here we have angle A, I'm sorry, side A is 46, so this side is 46. Angle X is 37, that is this angle. And we're trying to find C. That means we have opposite, and we're trying to find hypotenuse. Opposite over hypotenuse is sine. That means we're going to do sine of 37 degrees is going to equal 46 over C that we're trying to find. Let's use another variable instead. Again, we swap them. That's going to make it easy to transition from one to the other, so you can solve it for C. Sine 37 degrees. Punch in a calculator. And you are going to get approximately 76.44. So this can be used for some application problems. We can find some things that are called indirect measurement problems. We can figure out some of the dimensions. So what we have here is a tree. We're 75 degrees away from that, and there's this line here forms a 40-degree angle between the top of the tree and the ground. And we're trying to find the height. We know this distance. This is opposite. This is adjacent. That would be tangent. So tangent 40 degrees is going to be opposite, which is h divided by adjacent. And that's what we get. So multiply both sides by 75. H equals 75 times tangent 40 degrees. And we multiply that. And our answer is going to be 62.93. 3 feet in this case, because we actually have units. Right? Example 6. Connie is looking at a plane flying at an altitude of 2,500 meters from her window. The measure of the angle of elevation from Connie to the plane is 23 degrees. What is the distance from Connie to the plane? So we're talking about this direct distance. This is 2,500. Let's see what we have. We have, for that angle, we have the opposite, and we're trying to find hypotenuse. That would be opposite over hypotenuse, that is sine. So we're going to set it up as sine of 23 degrees is going to equal to 2,500 divided by x. So again, we have x on the bottom here, just swap these two. X is going to equal 2,500 divided by sine 23. 2,500 divided by sine 23 degrees is going to be 6,398.26 meters. Alright, this is actually a very interesting problem. So what we have here, let's make sure we understand. We have a castle, and there is some kind of a obstacle here. We have water, so we can't really measure the distance from the bottom of the castle wall to somewhere to do it the same way as the other problems were done. So there is a common approach for problems like that when for some reason you have you cannot access the very bottom of your object. What you do is you take a measurement of angles from two different points, and as long as you know the distance between these 2 points, you can set these up. So there are two triangles that we have here. Well, I'm going to call this distance here x. So we're going to have one triangle, which is going to be the bigger one, in which this angle is going to be 30 degrees. This side is h. This side here is going to be 45 plus x, or x plus 45. And then we have another triangle, and the other triangle we're going to have this situation. So it's h, this is going to be just x, and this angle is 50 degrees. So from each of these triangles we can set up the ratio, the expression that's going to help us find all this. In each triangle you're working with tangent because you have opposite and adjacent, and don't worry, we do have two variables, but we will be able to get rid of one of them. So from this triangle here we have tangent 30 degrees equals h over x plus 45, opposite over adjacent. From this triangle, we're going to have tangent 50 degrees equals h over x. Okay, so what I'm going to do is I am going to switch, just like we did in previous problems, switch this bottom value with the tangent. So what I can write then is that from the first expression, x plus 45 is going to equal h over tangent 30 degrees. So that's from this expression. From this expression, I can write that x equals h over tangent 50. There's a bit of an algebraic work involved here, so you do need to have some solid understanding of how to do that to solve this problem. It is not a hard problem, but it is a little challenging. So what I'm going to do now is, if you can see, this expression here represents x. So what I'm going to do is I'm going to substitute this expression for x right there. And I'm going to rewrite that. This way I will eliminate x from my expressions, and I will only have h left, which is what I'm looking for. So I'm going to have h over tangent 50 degrees plus 45 equals h over tangent 30 degrees. So what I need to do is I need to combine my h's together. So I'm going to subtract this quantity here on both sides. Okay. So I'm going to continue here. I hope I'm going to have enough room. What I have now is that 45 on this side equals h over tangent 30 degrees minus h over tangent 50 degrees. What I can do is I can factor out h, which will leave me with 1 over tangent 30 degrees minus 1 over tangent 50 degrees. And what I'm going to do now is to calculate h, I'm going to take 45 and divide it by this entire quantity. You don't need to worry about multiplying that, it's going to go in the calculator anyway. So I'm going to write it as 45 divided by 1 over tangent 30 degrees minus 1 over tangent 50 degrees. Okay? So all we do now is we have to, hopefully you have a calculator that does multiple operations at once, so you don't have to do it all step by step. So we type in 45 divided by parentheses 1 divided by tangent 30 degrees minus 1 divided by tangent 50 degrees, and press enter, and I got the answer of 50.39. So that means that this wall, the height is going to be approximately 50.39 meters. And that is the answer. This is actually one of the most challenging problems, but this is something that is used sometimes for measuring heights of objects that are not going to be accessible. All right. One other thing when you talk about how do you find measures of angles when you know at least two sides in the right triangle? Well, what you do is you can rely on using trigonometry. There's something called inverse trigonometry, and I'm going to explain that in a moment. So from this angle, we're trying to find the measure of angle, from this triangle, we're trying to find the measure of angle T. So what can I determine from angle T? Well, if I use opposite over adjacent, that's tangent, right? So I can write that tangent T equals opposite, which is 33, divided by adjacent, which is 56. To find T, I do what's called inverse tangent. It's arctangent of 33 over 56. Another way it is, well, if you're looking for that in your calculator, it is going to be tangent to the -1. That's what you're going to press. It is the same thing, it's just two different ways of writing the same thing. And then you type it in the calculator. It's usually right above the tangent key, so you usually have to use the second register. So inverse tangent of 33 divided by 56 is going to give you an angle of 30.51 degrees. So this is going to give you 30.51 degrees. But I want to show you something else. Do you have to use these two sides? Because you actually have all three sides given to you. Can I use another pair? And the answer is yes. You just have to use the right trigonometric ratio. For that angle again, this is opposite, this is hypotenuse. Opposite over hypotenuse is sine. So we can set it up as sine of angle T is going to equal to 33 over 65, which means inverse sine, so arc sine of that angle is going to give me T, which is this notation on the calculator. And you punch it in, so that one's going to be above sine key usually, divided by 65. The reason I wanted to show you this is because we are getting exactly the same angle measure. Okay, it's important to understand that this is actually going to produce the same angle measure regardless of which of those you use. Okay, we have a couple more examples. In example 9 we have to find the x, and then we also have to find the measure of both acute angles. Well, so here's what we're going to do first. To find the value of x, we can use the Pythagorean theorem. So we can say that x squared plus 9 squared equals 14 squared, which means x squared plus 81 equals 196, which means x squared equals 196 minus 196 minus 81 is going to give us 115, and x is going to be square root of 115, which is square root of 115 is about 10.72. So this is the length of the side, and all we need to do now is to find at least one acute angle. So let's say I want to find this angle. Let me call it y. So if I'm trying to find that angle, this side, for that angle, this side is opposite, this is hypotenuse, that will be sine. So sine of y is going to be 9 over 14, which means y equals the inverse sine, or arc sine, of 9 over 14. And if you do this on the calculator, you will get about 40 degrees. Okay, I don't need to do it another way. And one other thing, that we need to find one more angle, but now it becomes a very simple problem with the right triangle, because we have one angle that's 90, this angle is 40, and if you do simple math, this angle is going to be 50, and your problem is done. Okay, so we got the whole thing done. Okay, we got one last problem here. We have this ramp, which is 12 feet, so the distance between the base of the ramp all the way to that part is 12 feet, and over here it rises 3 feet, so we need to figure out the angle. And what we're going to do is we're going to figure out, okay, this is for that angle here, which I'm going to call x. This is opposite, this is adjacent, which means we're using tangent. So tangent of x is going to be 3 over 12. That means x is going to be arctangent of 3 over 12, and you punching in the calculator and you're going to get 14.04 degrees. Okay, and this is how you do these problems.